Okay, I just transferred the video to start on the chat on YouTube. Let me pull up the chat and see if they can hear us. Okay, cool. I assume they're going to let us know on the chat soon if they can hear us, which I think they can. Okay, everyone has the agenda. I'll share that in the chat right now. And we will get started. Okay, so we will start, as we did last week, with testing updates. I can get that started. I believe since the last call that I shared a very pretty simplified fork choice test. It's very abstract in the sense that it's not really talking about a lot of the data structures we have. It's more of just like building a block tree, saying what the recent votes are on that block tree, and saying what the head is. It seems like everyone that's taken a look at that has said that that more abstract version is better to reason about, and that won't be too much of an issue to build within clients. So I think we're going to move forward with that, which is very good. I shared some other ideas on state tests, which I know there are some pending comments that I have not responded to yet. But if anyone wants to chat about that now, the idea is specify a state, a starting state, specify blocks to transition, and then specify a resulting state or a resulting subset of the state if we're just testing some particular portion of it. I know Yannick had some...
I think you cut off, Danny.
Oh. Can you hear me now? No? Can you hear me?
Yeah, you were fine, dude.
Oh, okay. Sorry, I think that was local on me. Cool. Anyway, the state tests, those are the state tests and fork choice tests, I think are big for interoperability. So if you haven't taken a look at those, take a look and comment. And Yannick, I know you had some comments, and we can talk about them now, or I can hit them offline, and we can focus on that.
I think offline is fine.
Great. And then beyond that, does anybody have any updates on testing?
So we've started playing with Prismatic's chain test format, just to try and be like other people. So it's something we're doing. We're keen for the state transition tests when they come.
Great. And what does the format of the chain start test look like? Or do you have a link you can share?
Yeah, I think I saw a pop up from
chat.
Terrence.
Okay, great.
Is there any plan on putting that test in the Eth2 reference test repo?
Yeah, we can certainly do that. Yeah.
Oh, Terrence, sorry. Keep going.
Yeah, we can certainly do that. I can open the PR in the next couple hours.
Right on. Okay, because the only thing I was worried about is like it was GPL, and I'm not a lawyer or whatever, but like I was worried about any kind of copyleft implications because we're Apache too. So.
Yeah, me neither. We can discuss further offline.
Cool, dude.
I'm happy to finish your license. Yeah.
Cool. Yeah, and I'll take a look at those tests offline as well. Thanks.
Yeah, it probably needs to be extended a bit before it's particularly useful for the Eth test repo. I think it's a little bit more like internal sanity testing at this point.
I see. Okay. Great. Any other? Yeah.
Yeah, I've also discussed with Zach Cole from White Blocks this morning. So they are currently open sourcing part of their tests and simulation. And I will link to his 2 repo where he has some kind of structure to launch Dockers of various clients. And he has example configuration for Ethereum, EOS, Bitcoin, and so to create a network, a test network. So I'm sharing that in 2 seconds.
Cool. Yeah, I know he's been working on getting that open source. It's exciting.
Just a quick one from me, Danny. On,
yeah.
Just a heads up that the BLS reference tests in the repo are somewhat broken. I think the serialization format is incorrect. So I put added to an issue that's in there what I found, but I'm not making a big deal out of it because I believe the BLS stuff is all due to change in any case.
Right, and that had to do with the compression flag?
Yeah, the compression flags and the imaginary and real ordering is incorrect as far as I can tell compared to the spec, though the spec could be clearer on this matter.
Okay, great. One of us will take a look at that today. Thanks. Okay, anything else on testing before we move on? Great. Now we're going to quickly run through client updates. How about Pegasus starts?
All right, so this is Stephen Schroeder from Pegasus. We made quite a bit of progress over the last couple of weeks. We're in the process of upgrading to the 0.4 version of the spec. We have simulated blocks from a mock network adapter kind of running through the client, so we are running it in a closed loop emulated mode that's executing state transition and at the moment executing a simple fork choice rule, but we're ready to plug in LMD Ghost. Ben has been instrumental for helping us get BLS set up and running. Like you mentioned, we're still waiting on some integration tests for it, but we have BLS with Milagro for the working for the most part. And a couple of our next steps are just working with the other research team within Pegasus for integrating Handle, which is their signature aggregation library, and then perhaps making our state transition core pluggable so we can use their Wittgenstein consensus protocol simulation.
Cool, great progress. How about Trinity?
Oh, hi. Hello, Danny and everyone.
Hello.
So this week, 2 week, I think we are still working on sync with the latest spec, and because most of us are also part of the research team, so we try to sync the latest one version instead of the previous snapshot releases. And on the network side, our testnet may start with the Def P2P network with our current Trinity technology stake, but also Kevin from our team is also working on the Python binding with the Go libpp daemon. And there's a PI, and it's work in progress right now. And that's our update. Thank you.
Great, thank you. How about Prismatic?
Hey guys, we've been doing a lot of progress on getting our real runtime. So we're pretty much complete with v0.4 aside from some small bug fixes, and just really trying to get a simple testnet of like 8 validators and a beacon node running, just to make sure that we can advance the chain indefinitely. I think we'd advise everyone to be super careful when it comes to committees and like fetching committees optimistically. If you're going to do that at the start of an epoch, there's a lot of weird boundary conditions. So there are a lot of parts in the spec that specify like current epoch, next epoch, previous epoch. So if you're like, it's really easy to run into really scary bugs that just crash at specific epochs. So that's something we've been running into. But aside from that, we've been just optimizing that, adding more caching layers to items in our repo, getting things to move. We finished implementing initial sync of our beacon nodes to sync blocks since the last finalized ones and like state. But aside from that, our 8 validators are all like making money efficiently. Rewards are being applied. We're never more than 4 epochs in finality. So things are looking good. We've been just having some trouble with like assignment fetching and the seed changing at some point. So Danny helped us out a lot. But yeah, over the next few weeks, we're just going to be prepping more for like some sort of testnet release.
Yeah, great. And I was happy to work with y'all to find some of those bugs yesterday, which there's a couple PRs and there's another pending bug that we found that I'm going to get a fix up for. But thank you. Very exciting. How about Nimbus?
Hi. So similar to Prismatic, a lot of good work towards a simple testnet. And we concur, we also had a lot of epochs and slot issues that we debugged and that we are still debugging. In terms of spec, like we said 2 weeks ago, we are targeting 0.3 instead of 0.4 to reduce the impact of changes. And we now have full sync initial implementation for Beacon Chain and the block pool to deal with missing blocks to requests to other nodes. In terms of protocols, we have been working on RLPX on issues that benefits both Eth1 and Eth2 and discovery. And regarding Lippy2P, we also made progress in parallel to that regarding cryptography, because it relies on RSA, NIST, SecP, and ED25519 curves for various handshakes, and we implemented all that. So we will be able to use the full Lippy2P in the future. And besides, we have been working on the documentation generator so that we can have proper documentation when it's time to release that, so that the public can play with it. In terms of to-do, we have BLS multi-verify in the pipeline, and for the testnet, the main missing piece is fork choice. And also, like I said in the agenda and the sharding, I will be doing a presentation on Tuesday at ETC on Ethereum tests and simulation. So I will be focusing on testing because everyone is still working towards the testnet. And for simulation, we still have a lot of projects we can use, like what White Blocks has been doing, what Consensus has been doing with Wittgenstein, what Leo has been presenting so far, Leo from Barcelona Supercomputing. And of course, they can also play with the proof of concept that Vitalik did in Ethereum research repo. One thing that would be super helpful is I will refer to all implementer projects. So if you can add status on your README, like if you updating the installation, if you had some installation procedures, that will be like helpful. Thank you.
Great, thank you. How about Lodestar?
Hey, hello. Yeah, we, much like a lot of the other guys, we've had a lot of progress. We ended up not even hacking at Denver and just kind of working on our stuff. We got SSZ fully up to speed. We pretty much done with BLS in regards to porting over the using WASM. So we were using Harumi's library, putting down WASM. We've had to make a couple changes to it just to make it work for us. And that's almost done. We have SSZ imported into our chain. We're using it, and we think we have a branch running with BLS as well. We finished up all the state transitions. We found a few bugs in Epoch, and we've been kind of working through those. And thanks for your help there the other day, Danny, pointing to that issue yesterday. That was really helpful. And we're pretty much just like architecting out the last little bits of what we need to kind of what like the plumbing will look like when we go and hook up everything. Because we're prepping for simulations on our end. Hopefully in the next like week or two, we can start like getting it going and just like kind of breaking things and fixing whatever we have issues on.
Awesome.
And I don't know where my Kira is at with libp2p, but I know she's almost done porting over, adding some of the functionality there.
Cool. Thank you. Harmony?
We have added support of configuration files, so it's now possible to pass beacon chain parameters in the YAML file. Also added the command line interface for simulator. Then we've been playing around the general simulation scenario with just 4 validators, and found a number of bugs in the implementation and fixed them. Also, I have found a couple of issues in the spec, but our spec is not up to date, and those issues already fixed in latest version. So now one of the things we're working at the moment is updating to the 0.4 spec version. Also, we merged a patch 2 license finally, so now we're open source. And the next steps with regard to simulator is to try some unstable validators behavior when attestations are lost or blocks are not produced in some slots. But to start working on that, we need to finish current, we need to make the current general scenario work well. So yeah, that seems to be all from us.
Great, thank you. How about Parity?
So for us, we launched some really simple test nets for the Casper FFG, and it helped us to spot some the performance issues. Some of them is we can fix, so we managed to right now get around 10 plots per second. But our analysis is most of the time spent on importing block is for the BRS verification. Still, although we figured out it's not super slow, but it's still relatively not really fast. So, but in like for parity Ethereum, for a POA testnet, we can get like over 1,000 blocks per second. But so we are a little bit shocked that we can only do 10 blocks per second. But I guess it will be fun for real mainnets, because we will have, it's not a POA network and we have a lot of validators anyway. But this is something we spend some time looking into. And right now our focus is on runtime. We're still updating our spec to the newest version. So we got a standalone implementation of the committee and shuffling, but we haven't integrated into the actual state transition function. Yeah, I think we will also start looking to those test vectors, which we haven't before. So that's for us.
Great, thank you. And I think, although we will get some speed ups in the signature verification over time, there is going to be some like order of magnitude difference on being able to process blocks because of the the simple operation of checking the difficulty in proof of work versus the signatures. So, great. Eth, Dean.
So I updated to spec 0.4 version. Currently working on a bit of refactoring so we can clean up the spec or the implementation so it's no longer a one-to-one copy. And then still looking into networking. We found someone who already did libp2p headers in Swift. So I'm going to try and see if that works for us so we can use that. Then we finally managed to get BLS stuff compiling properly, but we're having a few issues with the bridging header. So we might move to a new BLS library, which Prismatic Labs recommended to us, but we're not fully sure on that yet.
Cool, thank you. Lighthouse.
Hey, yeah, so like everyone else, we've been doing some internal updates, optimizations. In particular, we've been caching committee info, which has got us to do some p-epoch processing with 16,000 validators in about 1 millisecond with pre-built caches. We're trying to work towards building, sub 1 second block imports. We've also been building the fork choice test framework that you were talking about earlier at the start, Danny. So we have like a working version of that, which will probably be modified once the actual framework comes out. We've also been starting to build out our core network syncing and service infrastructure, which we then have to link into our Rust libp2p gossip sub implementation, which also probably needs a little bit of work for chucking that in. And we also have a Rust developer starting next week to work with us.
Great. Did the gossip sub stuff get merged into the Rust libp2p?
It's not merged yet. It's it's in the process. There's a few still things that I have to update and fix with that. Nice. But I'll be doing that as we merge it into Lighthouse.
Cool. Yeah, I looked at that PR. It's a beast.
Yeah, there's a few things that the way that the Rust libp2p setup is very different to the Go libp2p, which makes things a little bit difficult.
I see. Okay, did I miss anyone? I don't think so. Okay, cool. I wanted to do a couple of quick intros before we move on to research. Mike from libp2p is here. I know a number of you met him at DevCon. He works with Protocol Labs. You want to do a quick intro, Mike?
Yeah, sure. Yeah, my name is Mike Gelser. I'm from Protocol Labs. I work on libp2p along with Raul, who's also on this call. And just joining to get a better sort of understanding of kind of what's going on with the Eth2.0 implementation. So I probably won't say a lot, but we'll listen carefully.
Cool.
Thank you.
And Matt Slipper is here, who has done some work on the networking spec recently. Matt, do you want to give yourself an intro?
Hey y'all, I'm Matt Slipper, CTO of Kyokin. We're a blockchain native consultancy. And I wrote the Phase 0 wire protocol and the State of Eth2.0 report with Amin and Dan. So really looking forward to helping out.
Great, thanks, glad to have you. Cool, anyone else that's new that wants to do an intro that I missed? Great. We will move on to research updates. Who wants to start?
I'm happy to start. So I've created a meta issue on GitHub called Miscellaneous Beacon Chain Changes Take 4. So basically it keeps track of some of the remaining changes that we'd like to make for Phase 0. Hopefully that will be the last such meta issue. So it's partly for visibility, but also just for keeping track of things. I've started thinking a little bit more about moving towards an executable spec as opposed to a spec with like human words. So I think executable specs will help kind of converge everyone and help with testing. So one of the things I did yesterday was submit this 10 ETH bounty for such an executable spec written in Go, and Diedrich, aka Protocol Lambda, seems to be working on that, which is fantastic. And there's this kind of constraints on the line count, and so this kind of forces a simplification mindset. So it's possible that we'll have inbound simplifications to the spec thanks to that. And it seems that Protocol Lambda has already found ways to simplify the presentation. One of the topics I wanted to bring up again is the SHA-256 versus Kitchak-256 design decision. Basically, to simplify, there's on the pro side of things, there's the interoperability, because many different blockchain projects are moving towards SHA-256. And then on the con side of things, there's security concerns. So one of the things that I realized recently is that it's quite likely that in the context of the standardization for BLS, for the #GG1, #GG2, that we would need standardization on the hash function. So if we do want standardization of the BLS, then it would definitely help to have SHA-256 here. And I guess one thing to mention is that Kitchak-256 will likely never be a standard that is adopted by the other blockchains, because they kind of missed the boat with SHA-3. So in that sense, Kitchak-256 is a bit of a dead end. On the security side of things, I think the main thing we want to make sure is that there's no deal breaker. And one of the pieces of good news here is that our hash function that we choose today to last decades necessarily. It's possible that 10 years is a sufficient kind of lifetime that we're looking to have. So one of the things that we're looking to do is basically ask Dan Bonnet what he thinks about the security of SHA-256. The two things that are known is, one, there's this length extension attack, which is, it seems mostly an annoyance, because in some cases you need to put mitigations to remove that attack. And then the other thing is that there's these kind of mostly academic security reductions, so like small attacks on SHA-256, which are in no way practical, but kind of not ideal, and Kitchak-256 don't have them. So I'll ask Dan Bonnet and see what he says here. So I think the design team is kind of moving towards the opinion that if there's no real deal breaker on a security standpoint, then we would favor interoperability, both at the basic hash level, but also because it has implications for things like BLS potentially. And the final thing that we discovered very recently is that Eth2 like clients might be more valuable than we thought, partly because there's potentially a denial of service attack on the fork choice rule, and so the attack is basically that an attacker could try and have multiple forks and force all the full nodes to kind of evaluate every single fork, and each fork has kind of a minimum amount of work they need to do, because you need to apply the epoch transitions at the very least. And so one way to get around this potential denial of service attack is to use light clients to evaluate the fork choice rule. So I might be spending a little bit more time on light clients.
Great.
That's it.
So on the SHA-256, one, we just want to give you an update on where we're at, and two, I know some of you have weighed in a little bit on that, but we want to make sure to get kind of the wide set of opinions on that, or at least technical perspectives. So I know there's some people have dropped some stuff in that issue already. If you have something to say right now, please say it, and if not, you can say it offline on that issue.
So I have one question, which is that, are you considering SHA-3 at all as a candidate? Because I think it's much more widely available in terms of implementations. So, and I guess it might have, 1-2 more years additional lifespan over SHA-256 because it was invented a bit later.
So one major kind of desideratum for hash functions is unfortunately like easy executability inside of the existing ETH 1.0 chain, because the deposit contract needs to be able to generate the Merkle branches. So we haven't thought of like SHA-3, the standardized version. We have thought of Blake, because I think Zcash was using, and I think they moved to some Peterson thing, hash-based thing, but they use Blake, might still be using Blake for some of it. And the main problem there is that basically like, there's not a kind of remotely gas-efficient way to do it inside of the ETH1 chain, which could end up like needlessly delaying launch by months.
Yeah, but there's no real problem with just adding a new primitive for like any hash function. So
yeah, I guess that's true. And actually, if we are going to go with a kind of more progressive hash function, then Blake might even be the best one, because I know like Zuko already wrote an EIP and I think might have even contributed some code toward it. So
basically, I mean, just like adding primitives like that, it doesn't like decrease the security of the EVM at all, or it's it's not a contentious issue or anything like that. It's just if any particular hash function is needed, it could be added. I do agree though that this might actually take some time because of the how slow the whole fork process is and everything.
Right, and so one thing to highlight is that SHA-256, other than just a couple of blockchains, is really becoming a standard that people are beginning to use. So one of the arguments is this interoperability thing, whereas SHA-3, even though yes, it's more standard across the industry, the wide industry, is not necessarily being picked up by blockchains to be used.
And do we know what Blake is being used by the way?
Polkadot.
Polkadot. Yeah.
But I should talk to Polkadot, because their whole selling point is interoperability, and so it seems like a strange choice of hash function to go against the whole industry.
They might be, depending on the speed up gain.
Yeah, I dropped into the discussion the multi-hash from Protocol Labs, which kind of works around all of this. Seemed to be quite well received. Is that being considered?
Well, multi-hash just means like you have a choice of what hash function to use, and that's not really something that we can do because a blockchain requires everyone to use the same function, or at least if like people use multiple hash functions, then they would all need to be calculated.
Yeah, and I mean it would have to be, multi-hash is basically a way to label a hash with the hash function that it created that value. So it's useful sometimes, but
And specifically, we'd still need to even if we wanted to support multiple hashes, we still need to coalesce upon the hash that will be used inside this deposit contract that is within the EVM.
Right, but it doesn't have to be the same as everything else. So that could be flagged by the EVM as a Ketrack 256 as it is, and we can just use something else for everything else we do. And as long as we label our outgoing hashes, it doesn't matter, does it? I mean, everyone can calculate according to the right hash what the state root is, depending on what they've received.
I guess like in terms of interoperability, like what blockchain are we even considering that could conceivably have an ETH2 Lite client inside of it? Like the main target that I can think of is basically like ETH1 and.
I think if it's to be used as a parachain on Polkadot, that they would need some sort of light client, and maybe similarly in Cosmos.
Okay. Do we know what VM does Cosmos use? Because like I guess the other consideration here is that like for any chain that's using like any of these WASM derivatives, then maybe they're fast. Like any of hash functions are fast enough to reasonably execute directly.
I don't think Cosmos has an enshrined VM. I think there's a distinction between the VM and the consensus layer. But I'm not.
Right. Oh, right. So with Cosmos, I think like the way they do interoperability is they require the nodes to like, also like run specific like software, which is basically a node of the other chain or something.
Or something.
If that's the case, then like it doesn't matter at all because we'll just run like our software.
Right. So even if we decide to go on like a self-describing hash, like a multi-hash, we still need to decide on some subset of hashes to use, right?
Regarding multi-hash, I think it was supposed to be a way to ensure upgradability. Like we say, okay, we use multi-hash, but we only use SHA-3 or SHA-2 or Blake. But if like 5 years from now, we want to upgrade the hash for whatever reason, it's easier when we are already using multi-hash because it takes care of versioning and other things like that, which is also an issue in SSZ, for example.
I don't think it'll be like too hard because like everything that is signed is like, for example, right? Like there's already this signature domain which represent, and that signature domain encodes the fork ID. So there's already a kind of standardized mechanism for like basically determining kind of which or which fork era objects came from. And so if you want to just like flip the hash function from one to another at some cutoff point, you could do that. Well, I guess the other issue is that it doesn't really make sense to be able, like the place where multi-hash makes sense is when you want to be kind of be able to support objects that other people create with different hash functions. But here we're talking about blocks, and if you have to kind of be open to the possibility of a SHA-256 block and a Blake block and a Ketchak block and a MIMC block, then what that basically means is that you actually have to calculate, like keep all 4 state roots calculated for every block, so which increases your work by a factor of 4, and then so that you can verify like any one of them that you would need to.
But it solves the, it could go some way to solving the interoperability with Polkadot, for example.
Well, not like, I feel like we've been using the word interoperability without really kind of thinking about where the interoperability issue is, because I don't feel like the interoperability issue exists because we don't have like EFS compatible byte-free prefixes somewhere. Like, so for example, the interoperability between ETH2 and ETH1, like the only issue there is that ETH1 currently only has kind of efficient support for SHA-3 and SHA-256, right? Or Ketchak 256 and SHA-256. And like if we add one more precompile, and I think like Felix is right that honestly a hash function is pretty much the safest precompile that we could add, given that it's just copy paste. It will a precompile and repointing a library. Then like we could add one more into the mix. And then say ETH2 to Ethereum Classic, if like they want to do that, then they would need to like add the same precompile unless we either use SHA-256 and Ketchak 256 inside of like. And then once we start talking about other chains, then it's a matter of like what scripting language do they have, and if their scripting language supports WASM, then like maybe actually our hash functions can be executed in WASM fast enough.
what's the resistance to using the multi-hash format? Like, I get that there's another workaround. It just seems at a glance like it's just a little bit.
Well, the format is just basically like having one of the really nice aesthetic things that we have in the current spec is that pretty much everything is a power of 2. And once you start adding prefixes to things that are 32 bytes, then they either balloon all the way up to 64 bytes or they're not a power of 2. So you do, and then like you have to start, like we have to start like changing around the lengths of all the different types, and it starts getting complicated.
I mean, also in general, like Vitalik also kind of explained it earlier. The main thing about multi-hash is that it's useful if you are dealing with a situation where people actually want to use many different hash functions for different purposes. But like in terms of, you know, Ethereum consensus, there is really only one way in which objects can be produced and hashed. So it doesn't really matter so much, you know, to you know, support arbitrarily many hash functions and being able to, you know, tell them apart.
Right, and to be interoperable with Ethereum is to just support and know that there's a hash used on Ethereum and use that, rather than having to like arbitrarily be able to like read it on the fly.
Yeah, I think having a single hash is simpler. It's just that we don't want to paint ourselves in a corner in the future. So even if we don't use multi-hash, just make sure that if we need to change hash function in the future for stacks, for example, we are able to do so without re-engineering everything.
Yeah, so I think we are, and like, I mean, I'll describe again like how that would happen, right? So like every single object that, so first of all, like if we have a hard fork to change the hash function from function 1 to from, let's say for example, from like MD5 to SHA-1, just to use totally stupid examples, then up until block 1 million, everyone is like happily churning along and using MD5 for their hash. And then after let's say 1 million is the fork block, like at 1 million, there would be a state transition added that basically says, well, not even a state transition, it would just say, oh, from now on, we're checking the state roots and we're checking block roots and everything using SHA-1 instead of using MD5. And so clients would need to kind of very quickly burn through basically rehashing the entire state, which they could probably do in like something like half a minute. And that would be kind of temporarily disruptive, but it's only one time. And then from there on, any blocks after the transition would just be hashed with SHA-1. The one corner case that you'd have to cover is if an attestation got created of a slot before block 1 million and it got included after 1 million, then like basically even though it gets included in the kind of quote SHA-1 era, it would still be using the MD5 hash function, but there already is infrastructure for like handling that case, which is basically the like anything which is BLS signed has this domain attached, and which basically includes like which includes which fork it's from, and so you would be able to just go along with that and use the hash function based off of what the fork domain is that got specified. So it's actually pretty low complexity.
Okay, to recap before we move on, we're going to get kind of a security briefing on SHA-256. Seems like there's a little bit of a motivation to try to get Blake into ETH1. I don't think that getting Blake into ETH1 within this calendar year is, I mean, maybe there will be another fork at the end of this calendar year. So but anyway, counting on Blake being in ETH1 seems like not something we should do for this year. And then even if we are to support multiple hashes, we need to support one of the hashes inside of ETH1, which is SHA-256 or CAC-256, for handling these deposits. and for handling some of the fun things we want to do by exposing the ETH1, the ETH2 state root in ETH1. Multi-hash seems to me like it doesn't bias that much, but we can continue to talk about this offline. Great. Let's move on. More research updates. We're still in research. Vitalik, do you have anything you want to update us on?
Yeah, actually. So on things I've been working on, first of all, there is phase 1. So I wrote up a couple of an updated PR for the proof of custody game, which is number 682. And the main thing there is that the game is basically the same as it was before, except with a couple of fixes. But I managed to move the state objects kind of outside of the validator record, so the validator records can be kind of perfectly fixed size again. So yay. So with phase 1, you can like click on phase 1 directly from the kind of main Ethereum 2.0 specification section. The one PR that hasn't, 682 hasn't really been merged in yet, but honestly probably should be, given that it's like kind of with a bit of feedback, you can like review it could be like as mature as the rest of the document. But like in general, there's just to go through it a bit, there's two major sections to it, where the first section is shard chains and crosslink data, which basically describes how shard chains work, how persistent committees work, who can create shard blocks, what the shard state transition looks like, and also what the data is that should go into this crosslink data root object field, which we're currently leaving empty during phase 1, or sorry, during phase 0. And we also talk about the fortress rule for shard blocks. And then the big section 2 is updates to the beacon chain. And that basically adds the proof of custody game, both kind of not like one-round interactive branch challenges and multi-round interactive like proof of custody bid challenges. So there, in terms of like what still could be done for phase 1, I opened up a checklist, which is issue number 686. So there's 7 items there. So the first is basically like, are there kind of substantial simplifications or we can do the proof of custody game? Might be possible. I've tried for a week and haven't really found any yet. Number 2 is grammar fixes and edits. Number 3 is naming changes. Economic review is number 4, which is basically just verifying that the rewards and penalties kind of make sense and do what they should be doing. Number 5 is the kind of multi-branch. Number 5 and 6 are basically optimizations that allow us to kind of reuse Merkle, like a large part of Merkle branches, and reuse attestation data to kind of challenge for much larger pieces of data at the same time with relatively low efficiency losses. So like on net, it's a potentially huge efficiency gain. And then number 7 is another one of those kind of very separated out farmable research problems. It feels kind of very similar to the design a shuffling function problem, except this time it's design a mixing function where the goal is to be friendly to multi-party computation. So those are kind of phase 1-y things. People are kind of encouraged to read, encouraged to comment, and so forth. Phase 2, I wrote a document on that. So basically issue number 702, which is kind of much more preliminary, kind of exploratory, which is things that we even need to decide for phase 2. And I have a bunch of items there. Another thing that I mentioned is, Axic and I started a brief discussion on how EWASM would fit in, and basically what the EWASM interface would look like. So that's like a discussion that's worth starting to participate in, I guess. beyond phase 2, I also wrote up a document where I made a proposal for what CBCifying the chain might look like, much more concrete. So that's number 701. If people want to look through that, they can feel free to. There's also smaller improvements that I figured out. So one of them is, hold on, where is it now? A number 685, which is a change to how validator balances are stored. So that's basically, it's there to provide two benefits. One of them is reducing the hashing that needs to be done. So, and the second is to reduce the size of a light client proof by somewhere between 1/3 and 1/2. The one other thing that I calculated is also just like the amount of hashing that needs to be done every epoch. And right now, like if we include this optimization, then the amount of hashing that needs to be done every epoch is 64 bytes per validator for the validator balances, because 32 and then multiplied by 2 because it's a Merkle tree, plus 45 bytes per validator to compute the shuffling function. And the reason why it's 45, or sorry, not 45, not bytes, it's 64 bits per validator, and then 45 bits per validator. The reason why it's 45 and not 90 is because like really in every round, you only need to compute half of the possible values. So in total, that gets us to about 109, which could help figure out like basically whether or not the current design is reasonable in terms of how much work it forces on validators. That's probably those are the I don't know, big things at this point. And then also the other thing in terms of executable spec, I'll probably make some PRs to try. So like I did an experiment for phase 1, which is to try to write phase 1 much more heavily in terms of Python code than in terms of like English bullet points. And it seems to have worked well. And I think I can make some PRs to turn the phase 0 spec into something closer to that. So kind of keep it exactly the same in terms of meaning, but write it out in terms of code. And that would, I think, improve clarity and probably also make it more executable, which should help with testing and finding bugs and so forth.
Cool. Any questions for Vitalik before we move on? Great. So the phase 1 stuff is beginning to enter into that kind of iterative design process like we had in the phase 0. So if you want to get your hands dirty and take a look at it and even write some code, know that although the core functionality is there, that it's going to be continually kind of reworked and ironed out and perfected. Well, perfected is maybe not the right word. Made better. Anybody from the Pegasus team want to give us a research update?
Yes. So like Steven already mentioned, we had discussion with Artemis team on how to integrate our signature aggregation framework into Artemis. And we are also testing the quick transport protocol, and we are adding new functionality like blacklisting Byzantine nodes. And that's all. Most of the team is on holidays.
Great. Thank you.
Is that handle?
Yes, it's handle.
Leo, do you have a brief update for us?
Yeah, not much to update. Just a quick comment. I had a contact with Ken and Jake from the Ethereum Foundation last week, just to have a quick update on the progress on the grant and the simulator. And they advised me to write a blog post showcasing the simulator and the work that has been done. So if anybody has like
ideas of something that you would like to see in this post or comments or something like that, please contact me. So, because I will be writing this in the next couple of weeks. So yeah, that would be all.
Great, that sounds awesome. And if you want to share a draft with some of us for review before you publish, we're happy to take a look.
Great, thank you.
Any other research updates before we move on?
I had a question for Justin. Is there any GitHub issues about the fork choice DOS attack?
No, but I think it's something that was found like today or yesterday. Yeah, we'll write up something.
Okay, thanks.
Great. Okay, moving on.
Actually, one thing I wanted to kind of quickly bring up is like, in terms of just efficiency of like execution, it would be like, are we at the point where clients can give concrete numbers to like basically like the goal that I think that we're going for is that it should be at least possible to execute, especially the epoch state transition within like less than and hopefully considerably less than 1 slot, even at the kind of maximum 4 million validator level. So do we have kind of statistics on executing the transition with that number of validators? And if not, kind of how far away are we from actually being able to come up with numbers?
Yeah, I've been playing with numbers quite a bit. That seems reasonable. The thing that's really slowing me down at the moment is the shuffling. It seems like the get permutated index is 1,000 times slower than the previous shuffler, which is kind of interesting.
So that's only if you kind of executed the naive way, right? Actually, Shelly, do you have that piece of the piece of optimized code that I came up with?
Oh yes, I will post it.
So basically, it's always important to remember that what goes in the spec is often not an efficient implementation, and in this case, that's definitely true. So you definitely can't, the code. The optimal implementation is like something like over 100 times, possibly like faster than just the naive way of doing it separately for every index. And as I mentioned earlier in this call, I think even the optimized implementation is suboptimal by like up to a factor of 2 in fast languages. The reason being that you can only, hold on. Oh, I see. 2.0 specs. Okay. Now the reason basically being that instead of hashing through the entire kind of list of validator indices in every round, you would only actually need to hash through kind of the half that is a possible kind of maximum of like x and pivot minus x for any round, and so you actually can like cut the hashing down even further by a factor of 2. But yeah, otherwise that's something that I wonder if this like shuffle code should maybe live somewhere as an appendix.
Yeah, I think it would be handy to see the optimized stuff, because I know that the spec is not supposed to be optimized, but most of it you can figure out. It's just normal programming stuff. But that shuffling algorithm is pretty intense. So if someone's already thought through it, it'd be pretty cool to share.
Yeah, go on.
Yeah, so we also had this issue on the Nimbus team. So we first used the naive way, and we couldn't do the epoch changes in the time for 1 slot. But we re-implemented the shuffling using a proto-lambda implementation, which is in Go. We ported that to NIM, and it worked quite well. Though we still had issues with timing. So in the end, we compiled with optimization for the slow parts to work around that. But we will do optimization later. But we still we already have someone looking into like parts that could be optimized.
Do you have like concrete numbers for how long it takes to shuffle like a long list of some length? Like a concrete.
Yeah, so I've been doing 16K validators. With the old shuffling, the Fisher-Yates, it was 1 millisecond. And with the new one, which was so the new one that's like slightly optimized, where you don't do that first hash every time, you just like cache the round count hashes and then just read them later. With that, it's at about 1.4 seconds.
1.4
no, maybe less.
seconds for 60K?
Sorry.
Oh.
Sorry, 0.8 milliseconds for the original shuffle, 800 and something milliseconds for the one that I wrote.
And the one that you wrote is, hold on, the one that you wrote is the one that uses like get permuted index for everything?
Yeah, it's that, but it doesn't. It's like slightly modified, so it doesn't. So that first hash is, I think, stays the same across all shuffles. So it just calculates out that that first 90 hashes and then just reads them instead of doing them every single time.
Oh, I see. So this you're just talking about the round keys that are used to compute the pivot, right?
Yep.
Okay, so the thing that's called hash bytes in at least like this optimized implementation, like you're still not, like you're still basically recomputing it.
Yeah, the pivot one I'm recomputing. So I'm just trying to find it so I can be familiar with it.
Okay, no, I guess so.
It's poll 576 if you want to see the like optimized one Vitalik's talking about. It's in the chat.
Oh, okay, thanks.
So in the chat, I also said the protocol lambdas Eth2 shuffle, and if I understand his benchmarks properly, with 4 million validators, which is the worst case, it takes 1.25 seconds.
Is that 40K or 4 million?
4 million, I think. Yeah, 4 million.
If so, then problem solved.
Yeah. Do you want to talk about that, Derek?
Yeah. Aside from shuffling, there's also like recomputing validator balances. Do we have numbers on that?
We haven't done the tree hash caching yet. Is that the question?
So this actually doesn't require the like fancy tree hash like change one at a time thing that I talked about in the last call. This is just the validator balances, because in an epoch transition you have to recompute basically everyone's balance, right? So this is just reconstructing the whole tree.
Maybe we could create an issue with all the benchmark questions so that we can everyone can put their numbers in there.
Yeah,
Sure.
that's a good idea.
That's a good idea.
We can probably take the rest of this offline.
I would just add one more thing to the performance issues, and that is keeping state copies around, which is a little bit of a problem. Because sometimes, for example, the way the spec is written right now, to determine whether a block is valid, basically you need to apply it. And if it's not valid, you need to roll back. That basically means that you need to keep a couple of state copies around, or at least somehow manage this complexity. And there are a couple of obvious optimizations here to do, which are all centered around splitting up, because currently the spec is written with this beacon state in mind, which is this big monolith. But if you, like, one optimization that we will be doing is to split up that beacon state into more independent operations that maybe can be done in parallel, but whatever. But at least they can be applied partially, and that would help a lot with these rewind kind of scenarios.
So the other
we're not there yet.
Yeah, the other idea I've had for that is that basically you can store states going back exponential intervals. So you can store the most recent state and store the state a block before and store the state 2 blocks before and store the state 4 blocks before. And then if you get a fork that's like not a power of 2, then you would just recompute up to that point. So that way you would just have to store like basically the size of the state multiplied by log n.
I think that's a slightly related
yeah,
issue. Yasek's maybe talking about like the fact that if I'm applying a block and I don't know if I need to revert it, as I'm doing that, I need to store maybe in memory more than just one state. I'm having like 2 or some diff on 1 plus something. So like the effective state in memory that someone needs to handle is larger.
So I guess like the mechanism I'm suggesting would definitely involve like holding log n copies of the state in memory, or like at least a few copies of the state in memory. Like you can save to disk past some threshold, and then you just like one of those copies would just be like a working copy, which is the block I'm processing right now.
Yasek, as you
means
do,
a lot of recomputing. Like naively, that means a lot of recomputing. Because
right. I guess like the one thing that is just worth like keeping in mind again is that you want an implementation that does not run out of memory in the worst case of 4 million validators. And if you want to have something that has like a very clearly bounded memory, then like just having log n like copies of the state is one way to do it. But then if you're using some journaling trick or whatever, then as long as it's as long as you can bound memory consumption, then that'll be fine.
Yasek, as you do that exercise and splitting things up and seeing what can be parallelized, please report back your findings.
Yep. Yeah, totally.
Cool. Okay. Anything else research? I want to get to talking about this wire protocol briefly. So for that, anything else on the research side? Okay. Matt turned some of the notes we had about the wire API into a more concrete wire protocol. Some of you have already commented on that issue, and I know there are a few more things that we need to respond, and I'm going to get to that today. Do we have any questions, comments, concerns that we want to address right now on the call related to this?
I can answer Felix's question about RSA, because I've had a couple people ask me about RSA. So the libp2p specification requires a key pair to be associated with each node on the network. The default key pair is an RSA key pair. I believe it's possible to change it, but there does need to be some concept of a key pair, a network identifying key pair associated with a particular node on a libp2p network, because all of the peerbook and basically node identification logic in any libp2p library in the spec relies on that key pair. So we can reuse key pairs from other places. It just has to be some pair of some encryption algorithm.
Yeah, I understand. I just think that depending on, I'm a bit unsure in general with this specification what the sort of which level this is actually sitting at. I mean, is this supposed to be like a complete specification of the entire protocol, including basically which bits go where on the wire, all the way up to which message types include which consensus objects? Because
but the I added a little bit of a sort of additional context in there about libp2p because I'm not sure what the sort of collective familiarity is with libp2p.
Yeah.
So it extends a little bit. So the fundamental goal of the spec is to provide, these are the bytes that go over the wire. These are the the equivalent of endpoints that those messages go to, as well as like how they are transported, compressed, etc. With an additional bit of info about libp2p on top.
Mm-hmm. Yeah, I do think though that this general concept of how node identities work and how they handle everything doesn't really belong in the same spec as the sort of high level message high-level message types that are being sent and stuff like that. So
I
would kind of recommend to maybe even, sorry, I'm talking so much. I'll be done in 5 seconds. Maybe the other thing that could be useful would be to more clearly separate. I mean, there's already a separation between the protocol that is spoken between 2 individual nodes that is probably going to be used for syncing, and the broadcast. And I feel like maybe it would be kind of nice to even make these like totally separate specifications, to have these sort of like what goes on the broadcast channel, be that in one spec, and then having like the actual sort of sync protocol as an independent specification. I'm not sure if that would help, but I feel it's would be kind of useful.
I hear you.
I would mirror Felix's comments, and I would add to that it's a little bit sprawling as well in terms of encodings used. Like if you look, there's like base 64, base 16. There's new line determinated strings. There's like binary little fields, and then there's SSZ, and it's just like a lot of. I think we should take a look at how to simplify it a little bit as well in terms of encoding, so that we don't have to have so many of them just to read a message.
Wait, which things are new line encoded?
I think the protocol, the message ID just did the thing before the compression. I don't have the word for it right now, but.
Oh, that's supposed to be just like a dual, or sorry, a byte, a single byte.
Yeah, so before the compression, there is like the message identifier, and that one is like this slash separated string, and I assume it ends with a new line, because how else would you know where it ends?
Protocol path, got it. Yeah, so that's just an artifact of the. So to support protocol paths, what the P2P does is it's just you're right, it's a string, the length of the accompanying a string, a new line, and then the length of the accompanying like byte body. That ends up being abstracted away by the P2P libraries when you use them, but they're included here to sort of show the whole bytes that will go over the wire.
I do want to interject.
So I think that.
Sorry, this is Raul. I just want to make a point there, because this spec was brought to my attention just a few minutes ago before joining this call, so I wasn't able to weigh in. But there are some misunderstandings as to how messages are carried, particularly the fact that each message is not prefixed with the protocol itself. You negotiate the protocol only once when you open each stream, and that stream is then tagged with that protocol. So some of these things will likely change. I'll make comments today.
Perfect, thanks, Raul.
Yeah, that's what I meant. So basically, the whole thing is basically this wire protocol is kind of like basically if you are assuming that all the messages are going to be carried across libp2p's multi-stream, likely the format is going to be a bit more complex than what it has there. There's upfront negotiation, all of that, and I think maybe this shouldn't actually be included in the spec, because the thing that we need to agree on, maybe at this moment, is more like a high-level message structure, and then exactly how these things are going to be multiplexed on a single connection and how the whole negotiation and versioning and everything works, I guess that can be left up to a later specification or to the libp2p multi-stream thing.
Yeah, I agree with you, Felix. I think ideally you'd be able to reference a well-formed, well-written, well-spec'd out reference in the libp2p docs, which we're working on. So hopefully it will be there soon.
Okay. Yeah. Raul, we welcome your comments, and we'll simplify and maybe get to the meat of what is going on here. And let's see. Oh, I did have a question regarding. Frank had a question regarding ENRs. If nodes are discovered using ENRs, the information node is already available. This means the client will be identified by an ENR if libp2p multi-adder is used. And if libp2p multi-adder is used and is not implementation detail, not a protocol requirement, question. So I guess the question is where ENRs versus multi-adders come into play.
I can handle this. So Frank isn't here. I think he's listening on YouTube, but he's not in this call.
Hey, Frank.
But basically, so the idea is that from our side, when it comes to the ENRs, they're more like a discovery type of thing, and I think his question was more related to how exactly
yeah, basically, maybe what the spec should do is like document the assumptions that it has in terms of like pre-obtained knowledge about the node that it's talking to. So I think that would be enough in this specification to just say, okay, in order to talk, in order to speak this protocol with another node, you need to know these 5 things about that node. And then, you know, how this information is going to be, you know, carried or, you know, relayed to you before you start speaking this particular wire protocol, that can be left up to a different spec, or, you know, I don't know. And I feel that will kind of answer the question. So and when it comes to relationship between ENR and multi-adder, is basically that you can put multi-adder into ENR. So that kind of, I guess that resolves the discussion there. So if you do want to talk about nodes using multi-adders, you can just put them in the ENR and then you're going to be fine.
Okay, cool. Thank you for the feedback. We'll continue the discussion on this issue, and maybe come up with a V2 or V0.2.
And when it comes to the relationship between ENR and multi-adder,
Lawrence, can you? I think we're getting some feedback if you're listening to YouTube. Okay, cool. We'll continue the discussion here. Next week we'll come out with a 0.2 draft addressing the comments, and we'll go from there.
Yeah, I should be able to split this up pretty quickly.
There were some other questions about the. I'm not. I hope this isn't the end of the meeting, because Frank and I had some more things to say about this stuff. So there's the ongoing debate also seems to be about the serialization formats, and this is actually a pretty big chunk of this debate on the issue has been about the serialization formats. So it would be kind of nice if we could, you know, settle this once and for all.
Serialization is next up. Any other comments on the wire protocol before we move on? Okay. Next up, our favorite topic, serialization. Felix.
Yes, awesome. So yeah, so I feel like, you know, from my point of view, it looks like the sanest option seems to be to just say that, you know, consensus objects should be encoded using SSE basically everywhere. And then, you know, how the actual messages are encoded is a bit, you know, up to anyone's opinion, I guess. So it will be kind of nice to hear people's opinion, and like, you know, what this is now specifically about the wire protocol that we're speaking between the nodes. And the question is, should it use SSE? Does it make anyone's life easier? Does it make anyone's life harder? What are the options there? So from my point of view, I can just say that basically we've been flying pretty well with RLP so far, and the main advantage it has over SSE is that it's a format that doesn't require a schema to decode. So you can just, it's a free form type of thing, just like JSON is. So it means you can just, you know, put a message there, and then sort of like you don't actually have to know what type of object is contained in a message in order to decode it. And then with SSE, that's a bit different, because it's basically just, you know, a collection of bytes that doesn't necessarily have any sort of self-describing structure, at least as far as I understand.
Right, it does not have a self-describing structure.
One thing was that, especially regarding the SOS spec that I don't remember Karalabe put forward, is that with SOS and SSE with a little work, you can have specific byte offset, so you don't have to read and decode the whole thing to get a specific field, and that was one thing that is clearly missing from RLP. And the other thing is that Raul from P2P said that they were looking forward to provide Wireshark dissectors, so that whatever we end up choosing as a wire serialization format, we have something robust to work with in Wireshark and others network analysis.
Yeah, so I wanted to that last comment. Wireshark has been, you know, a desired feature for quite some time, and it is definitely something that I would like to see. but currently the libB2B core team doesn't really have the capacity to work on Wireshark dissectors at the moment. So I'll be happy to engage with anybody who needs some guidance to work on this and to maybe get a head start. I have implemented Wireshark dissectors in the past, so definitely happy to talk about this. And there are some ideas, there are some things that need to happen in libB2B before we can facilitate creating Wireshark dissectors that can tap into the message and decrypt the message, because there are, as you know, libB2B encrypts messages by encrypts data by default. So there is certain instrumentation that we need to provide at libB2B to expose secrets to things like Wireshark dissectors and other tools in the future. So happy to talk about that offline.
So just a background on the simple serialized stuff. The goal, or the decision made months ago was, okay, this works very well for consensus, and at first look is fine on the wire, and in case of simplicity, to just go with until we decide that it is not sufficient for our needs, to utilize it for both. So that's just the context on the decision made there, knowing that it was not necessarily an optimal wire decision, but a something simple to just have across the board. That's it for me for now.
I would generally feel that embedding SSD within RLP feels a bit weird. There's a cost there.
So
that might be easier to avoid.
So why is it weird specifically? I'm asking because basically it's with RLP is kind of easy. I mean, there's only really two things. There's lists and byte arrays, and you could put anything in those byte arrays, including SSD blobs. So I don't feel like it's a. What do you mean from an implementation point of view, or what do you mean?
Yeah, from an implementation point of view, and also like because the value it adds is kind of minimal. I mean, in order to read the messages, you pretty much need to know what's in them anyway to make, useful use of the data. So having two custom serialization formats where one of them doesn't really buy, what would RLP buy exactly?
Nothing in particular.
Scan the data.
I'm not arguing for RLP in terms of, I just want to provide like the basic fact is that, you can decode it and you can see the high level structure of the message without necessarily knowing which field is what. And this is something that is, to my knowledge, impossible with SSC. But that doesn't mean that I'm like massively in favor of using RLP for this. To be honest, maybe that could be kind of overkill.
Yeah, actually, it's funny, let's say, because in July when we were discussing about serialization format, the main critic of RLP was that you didn't have any kind of schema, and we couldn't know the offset without reading and decoding the whole thing. So I guess it's either a plus or a minus, and we need to know for Eth2 what stance we take on that.
So the offset thing is kind of useful for, I guess it's most useful for things like blocks and stuff, because you do need to sometimes, especially inside of a consensus scripting environment like the EVM, sometimes it can be desirable to get, say, I don't know, like a bunch of attestations as an input, and then be able to quickly find a specific one without necessarily decoding the whole thing. So, and then, for this type of thing, having byte offsets is very useful, but for P2P messages, usually you'd have to decode the whole thing anyways, because you're likely going to deal with every part of it, and being able to quickly access a tiny portion of the P2P message isn't something that has come up a lot in the past.
I would counter that. On embedded devices and on any kind of resource restricted devices, it's actually pretty common that you want to access just a subset of a message. And then in order to gain access to some limited set of functionality, maybe not the full thing, but to be able to run a specific part of, or use a specific part of the information. And then it's actually a big asset to not have to go through too much decoding in order to get there. It's not, I agree that there's a stronger case for it inside blocks and so on, but anytime you want partial information, this is a useful property. I'll just add a trivial example here, like memory usage, right? If you have to decode stuff, you have to usually put it in a separate memory location, or you have to build up a complex structure that points out where the data is before you can use it.
So you will actually, well, I mean,
grow the needs of what, yeah. So you quickly just grow the amount of stuff you need to know before you can use the message.
So given that, you know, these messages are carried on a byte stream, I guess. I mean, in terms of libp2p, it's likely going to be carried on some kind of TCP connection, and you'll have to read from that TCP connection into a memory buffer. And so if you're on a very, very resource constrained device, then it can be beneficial to actually walk the data as you are receiving it, and then, you know, discarding the beginning of the data while you're already working on the next chunk or something like that. And so these types of things, we've actually done them with RLP in the past in the context of transaction signing on a hardware wallet. So there was an implementation by Nick Johnson for sort of a for an RLP processor that could essentially grab useful bits out of a transaction while receiving it. So, but in order to do that, you actually need to be able to decode it in a streaming fashion. So we have a streaming implementation of RLP available. So that's like, for us, this is kind of a non-problem. But I'm pretty sure that most implementations of RLP that you will find on the internet are not streaming. So they don't actually allow you to do this kind of thing. But in general, I mean, for most implementations, what they're likely going to end up doing is just checking how long the message is and then receiving the whole thing into one buffer and then working off of this buffer. So working in a very resource constrained environment where you don't actually have enough memory to even fit one single network message into memory all at once, I guess, yeah, you'll have to come up with a workaround there. Why, do you agree, or is it?
Yeah, I can agree with that. It was more meant as a general comment that every kind of additional encoding and difference in format limits the design space of what kind of smart things you can do. And I'll just leave it at that for now.
Okay. So I guess we won't really come to consensus today about, you know, the
this seems to be the core issue around Eth2.0 is serialization formats, because we keep coming back to it. I don't think we're going to decide today. With respect to the discovery protocol, Discovery v5, I know that RLP is currently baked into it. Is that decision, I mean, is that some sort of technical requirement in there, or does it not really care what serialization format it's using underneath the hood?
So it is actually kind of a, I mean, we're coming, I'm not sure, are we going to talk about this v5 in general now? Should I just, I don't know, or is it, yeah, maybe more about the serialization? So, I mean, we've been using RLP for a long time for discovery purposes, and I feel like it's been a bit beneficial there, because for the DHT, the main problem has been that sometimes it is kind of necessary to extend the protocol in a backwards compatible way. And for that, it's actually really useful to have this free-form format, because you can always just tag another field onto the message and know that previous versions of the client are going to ignore it. And because they, like, ever since EVE8 was published, which was way more than a year ago, implementations are actually required to ignore additional data in the message, but it's still encoded in the same way as everything else, which is, you know, as a field in some RLP list. So it means that we can actually tunnel, like for newer clients that need a certain feature, we can actually tunnel arbitrary data through the protocol if we need to. And this is something that I think is very, very useful, particularly for the DHT, because, well, yeah, implementations can be in various stages of compatibility with spec versions and stuff like that. So it's kind of useful to be able to just, you know, hack something into the protocol at a later point in time if it's needed.
I see. Interesting.
And so this is actually the main reason. I mean, from another point of view, I mean, it might as well use ASN1 or something. We don't really care. Probably it should even. I guess it's kind of useful to have it as a binary format. But also the other thing is that for discovery specifically, there's no requirement to have a serialization format that is consensus safe, as in that there doesn't need to be a single canonical encoding for everything, because, yeah, well, it's just basically we just need any serialization format. And yeah, well, we've been using RLP because that's also been used in the previous version. And in the ENR spec, we've also used RLP, and there it's actually required. Well, it's not, well, it doesn't have to be RLP specifically, but the way this works is because ENR is a loose collection of key value pairs, you kind of need something that can represent that. But I guess you could even build that with SSC if you absolutely wanted to.
Right.
Because all you really need is, like, yeah, variable length lists.
Mm-hmm,
so.
Okay. Thank you. Let's table serialization for the rest of the call. And we're actually at an hour and a half, but if you could give us an update on Discovery v5 and just status and things moving there, that'd be great before we close the call.
Okay. Yeah. So what we've been doing is basically we have now published a sort of draft of the specification over in the dev PDP repository. We're still working on it. Just now, I am rewording the requirements document, and I will add the topic discovery specification as well as the ENR spec in there probably next week. So, and then at that point we'll have pretty much a complete specification, but it's going to have a few rough edges. At the moment, I'm also working on implementing the whole thing. So I'm, yeah, I don't know, maybe like 40% done or something. So I do have the basic structure in place, but I don't have any sort of code to share yet. So that's that. And yeah, specifically about that repo. So this is something that Frank raised. So for us, it's been kind of hard to actually follow all the discussions because the P2P discussions have been spread around like so many different places. So this is why Frank has been advocating on the meeting agenda to, yeah, well, maybe move some of the P2P related spec work or something to the dev P2P repo because, yeah, well, it would make our life easier. But in general, the way people seem to be constantly confused about the term dev P2P and seem to think that it's like I don't know, like yeah, I don't know. It's kind of hard for me to understand why people are so confused about it. But for us, dev P2P has just always been the name for like whatever P2P system Ethereum is using at the time, and I will just continue seeing it that way. So this is also why we've just started specifying the new stuff in that repo, because for us this is like the repo for Ethereum P2P stuff. So if you guys feel the same, we can maybe consolidate the discussions there. If you guys feel that another repo is needed, or another place of discussion is needed, or another place for specs is needed, then we're happy to move our stuff there, I guess. But for us, it's just kind of been a bit weird because we feel like there is this repo, and it's basically the main purpose of this repo is to discuss and specify Ethereum peer-to-peer things. So I guess this is why we are asking to maybe consolidate everything under Ethereum Dev P2P, because it's the place for that.
Yeah, that's fine with me. We can maybe just make a tag related to 2.0.
Yeah, there's also now, I think there's now a feature on GitHub that allows transferring issues. So if you do want to transfer any issues there, or if anyone needs write access to that repo, we can give that out. At the moment, there's, I think, like 3 or 4 people who have write access to that repo, but if anyone needs it because they want to prototype a specification or something, we're totally happy to set that up.
Cool. Before we close, I have one question about one of the design decisions made on this this wire protocol spec, and it was erring on the side of more topics. So like having topics for beacon block routes, having topic for beacon block headers, having topic for beacon block bodies, rather than having just a topic for the beacon chain, having a topic for the shard chain number 1, etc., splitting it up into more granular topics. One, is there any sort of performance issue that you could see on maybe finding peers for these subtopics rather than just having the larger topics? And 2, is this unexpected or a strange use of topics and discovery in general?
Wait, so are you talking about pub-sub topics now, or discovery topics?
I guess both. Well, I guess they're distinct, right? Because I could, if I discover someone's interested in shard 1, then I could use some subset, some like extended set of shard 1 pub-sub topics. So you're right, they are distinct.
Yeah, so this is basically the thing. So I think the discovery topic structure is a different topic from the from the gossip subtopic structure, because
right, okay.
Because as long as you and all the other participants agree on like what broad range of things to talk about, you can just tagging the message with any topic is fine as long as it's going to reach you. So I think the main reason why we're even talking about having a sort of topic-based index in the peer discovery is because it's going to make it easier for larger networks where maybe you're not going to be interested in everything every other node has to say. But as soon as you get connected to a certain good set of peers that are roughly interested in the same things as you're pretty sure to receive all the relevant broadcasts. So
okay, cool. Yeah, I thank you for your answer, and I kind of sorted through something as I asked the question. Okay, cool. Heads up, I think I mentioned this last call, we are planning on doing a some sort of gathering before, very likely before EdCon in Sydney. There's enough of us there that I think it would be useful. Potential topics and breakouts would be like EWASM / state execution / phase 2 stuff, light client stuff, and testing / test nets, depending on where people are at. We aren't certain of a date yet. We're thinking maybe the middle day of the hackathon, which is the 9th, so that we don't detract from the opening and closing ceremonies by pulling a ton of us out of the hackathon. But we still need to figure out location and details around that. So I will keep y'all updated on that. Okay, we're going to close because we're 10 minutes over. Thank you, everyone. Good call. And talk to y'all soon. Oh, and happy Fork Day.
Thanks, everyone.
Thanks.
Thank you.
Cheers, guys.
Bye-bye.
Thank you.
Bye, everyone.
Bye all.
Thanks.
Thank
Cheers.
you.